Hi, welcome back to tutorial. In this video, we are going to discuss two things. The first one is law of exponents, and then we are going to continue with logarithms with base 10 and Euler number. Whether you're taking AI or AA at any level, SL or HL, this is suitable for you. Now, let's get into the laws of integer exponents. Basically, this content is supposed to be familiar already with you if you are taking the IGCSE mathematics and or the IB MYP mathematics. So in this video, I'm going to do a more intuitive approach for you to understand the laws naturally. The first one is a product rule. So if you have exponent with the same base and a different power, then you multiply them, it is going to be adding the powers. Let's do an example. If we have 4 power 2, we multiply with 4 power 3. We can expand them that on the left one, we have 2 of 4, and on the right one, we have 3 of 4. So in total, we have 5 of them. So that's why when we have same base exponent with different power and being multiplied, we can just add the powers. Now, on the contrary, when it is a division, you need to subtract the powers. This is the quotient of powers rule. For example, if we have 4 power 5 and then we divide with 4 power 3, we can just expand them and we can see that there are divisions happening which left us with 2 of 4s. So we will be having 4 power 2 in which the power 5 subtracted by 3 is 2. Now we are having a power of power rule, so in which the powers will be multiplied. Let's try on 4 power 3 and we power that twice. So it means that the 4 power 3, we have it 2 times. Considering the product rule earlier, we know that the power, we can just add them. So 4, 3 plus 3, in which it is 6. On the 4th and 5th, we have power of product rule and we have power of quotient rule. Let's say we have 4 times 3 power 2. This implies that we have 4 times 3 and also we have another 4 times 3. In which case we have 4 power 2 and we have 3 power 2. So you notice that this is the power of the product rule. It goes the same way for the quotient. So if I do something like this, it means that I have 4 over 3, another 4 over 3, which results me with 4 power 2 over 3 power 2. So basically, you can just try with any numbers and the definition of power exponents, which you expand them and you will get the same result. Number 6 is zero power rule or zero exponent rule. So in here, we're going to do a little bit of algebraic manipulation. So let's say if I have 5 power 0, this implies it is, let's say, 5 power 3 subtracted by 3, in which we learn that this is also equivalent into 5 power 3 over 5 power 3. So that's why the answer is 1. On the 7th, we have negative exponent rule, in which we get that using the quotient power rule. So let's say if we pick 4 power 0 minus 3, it means that we have 4 power 0 over 4 power 3. And from the previous one, we know that 4 power 0 is 1, so it is 1 over 4 power 3. The 8th one is fractional exponent rule. This implies how to combine the power with the root. So in this case, if let's say you have 4 power 5 over 3, now you can write it that it is 4 power 5 and a cube root, which you can also simplify into 4 multiplied by 4 squared cube root. Now, here is the summary for laws of integer exponents, in which you can take a screenshot and save them. Now, let's continue with the introduction to logarithms with base 10 and Euler number. So, logarithms is a way for you to ask about the power or exponent. Usually, when you are doing exponents, you're interested in the result. Well, the logarithmic is the reverse. You have the base and you have the result, and you are interested in the power or the exponent. So if you have a power x equals to b, then it means that the logarithm of a base and an argument will result in the power of x. So in this case, logarithm base 2 into 8 will result in 3 because 2 power 3 is 8. Now focusing on the calculator section in which it will help you to evaluate logarithms. The normal convention is when the logarithm with base 10, you don't need to write the base 10. So it is just the log symbol in your calculator. If you try log 100, this implies that 10 power 2 is 100, so that's why the answer is 2. And for Euler number, you can write it in log e, and let's say we're interested in the results of 7. Well, in the calculator, you have it in the ln symbol, which stands for natural logarithm. So the natural logarithm of 7 is 1.94591 ... From the first statement, this implies that 10 power 2 is 100, in which it is correct. For the second statement, Euler number power 1.94591 ... is equal to 7. At this point, it might be seem too simple or too easy. Well, it is because when you're taking AI or AA at SL or HL level, you are going to get different explorations of the exponentials and logarithms. And especially, you are going to do that in the function topic as well. So, stay tuned to this channel and don't forget to subscribe. Take a look at the dedicated playlist so that it will help your math studies.